It was.
Yeah, hilarious. That's how this podcast just started. It was my dad. Ha, hilarious. We have no backstory. It's fine. Okay. For all the one people that watch this. Oh, no. Okay. So we did polynomials, and you have a test on that on Wednesday. Then we're doing transformations, and you touched on this somewhat last year. Okay? And Mr. AP, you touched on this more last year.
Do I
So you know.
remember it?
Yes.
Probably not.
Fully you do. Okay, I expect all the answers from you. So, we're going to do horizontal and vertical translations first. Now, as we go through this, people are like, this is so easy. And then I put it together and it's like you guys all just start, it's just a bad, you're not happy. That's what you are. So, instead of that happening, what I have to tell you is you have to keep up with your homework. Okay? If you don't keep up with it every night, when we put all the stuff together, you'll be a lost soul. Like lost somewhere. I don't even know. Never Neverland? Not sure. But you will not be here understanding. You will just kind of want to curl into a ball and crawl under your desk. We don't want that. So, we are going to pay close attention. So today's lesson is the nicest lesson of the entire year because when it's by itself, it's just beautiful until it gets put with other stuff. But we're going to pay close attention. So when we did transformations last year, it was very small and it would have been only a quadratic. Now, because it was so much fun last year, they let us transform every single function in the world this year. Right? Like start with quadratic and then now anything. So fantastic. Only slightly harder. Okay. So a transformation is an operation that moves or maps a figure from an original position to a new position. You've been doing this since you were little. What's good about transformations compared to little? They don't make you rotate. Remember? Do you remember in junior high the ones that you could never answer were the rotating ones? Anyone? You were good with those? Or you just don't remember grade? Okay. The rotating ones are the ones that cause people the most trouble. Positive part here, no rotations. Okay? So we're just going to translate left, right, up, down. We're going to stretch wider and narrower, and we're going to reflect up and down, but no rotation, like you did in junior high. So, a translation is a transformation that slides each point of a figure the same distance in the same direction. So if we have it in the form y minus k equals f x minus h, or we can get y by itself, which is what I always suggest. I will always get y by itself like this. Y equals f x minus h plus k. We will always do the opposite for h and the same for k if you get into y equals. Now, what the heck does that mean? Well, that means that if I have x minus h, that's the way the formula works, right? Last year you had x minus p squared plus q. It's the same thing, but it's just quadratic. If you have x minus h as your actual equation, then if I had x minus 2, my h would actually just match up with the 2, wouldn't it? Not the minus sign, just the 2. So I would say that I would be moving 2 to the right because it's actually a positive 2 even though it looks negative, right? Because the negative sign's there. And then if I had instead x plus 2, well, I need it to have a minus sign, right? So how can I get a plus 2 with a minus sign? X minus, how do I get a plus sign from a minus? Negative 2. Good job. Good answering. Thank you. Smart people. Minus a minus makes a positive. And I need an x and a minus and an h, correct? So that's why when you actually have x plus 2, you're moving 2 to the left, not 2 to the right. It's the opposite. So you always go the opposite of what x is. Now your k's are always the same because it would be like plus 6, let's say. Well, it's plus 6, so I move 6 up. Or if it's minus 6, I have plus a minus 6, so I move 6 down. So the h's are always the opposite, right and left, and the k's are always the same, up or down. So that's why this one sounds weird. When h is greater than 0, that just means this piece, you move to the right. When h is less than 0, you move to the left. When k is greater than 0, you move up. When k is greater than 0, or less than 0, you move down. This is just like the general statement of it. We'll talk about mapping and replacement in a second. We're going to come down here for a second. Okay. There's an example at the bottom. It says, the graph of y equals f of x, so this is the original graph, is transformed, so it's moved, into this graph, right here. What did I tell you is the first thing I always do? Get your equation into? Yeah, y equals. So what do I have to move to get that equation into y equals? Plus 2. So the first thing I'm going to do is go y equals f x minus 3 plus 2. Now last year you could have gotten away with typing half your quadratics in and just looking at them because it was a quadratic and you could see what if it moved to the right or the left or whatever. But these ones have f's. When they have a little f in here, this is just another way of representing transformations. So this here is a fancy way for them to say, take this graph and do that to it. This is just transformations. This little f is saying, okay, the equation f, oh that's this one, I want you to do this and this. I want you to have x minus 3 and plus 2. I want you to do those transformations. So when there's an f in it, this is just telling me transform f of x in this way. If there was a g in there, it would just be transform g of x in this way. So it would just go with the g of x equation. So we don't have to just use f of x's, we could use g of x, h of x, k of x. We can use whatever we want. And the reason why we have that is because sometimes you have a graph drawn. And you'll have a graph drawn like this, and then you'll have a graph drawn like this. And then they tell you it's f of x and g of x, and you're like, I don't know which one's which. Well, they'll label this one as f of x, and they'll label this one as g of x, and then I'll know which one they're talking for me to transform. So that's why they'll label them different letters instead of just y's like we've used. Because in the past, we've only ever drawn one graph on a graph. Okay? Well, let's talk about the transformations. The transformations and the way we state them have to be, they're kind of listed up here, but we're going to list it down here anyways. They have to be listed in the form S, R, T. I call it CERT. They have to be listed in the form SRT, aka CERT. S stands for stretches. We have not learned anything about that, so we're not going to fill anything in there. R stands for reflections. Once again, we have learned nothing. T stands for transformations or translations, and translations are the horizontal and the vertical ones, which is what we're talking about today, correct? So we're not going to fill in anything into the S, we're not going to fill anything into the R, we're going to fill into our T's. So we can't do this in short form, we have to write it exactly how I write it. So I'm going to do vertical translations first. You could do horizontal, it does not matter. I'm going to do vertical first. So there is a vertical translation. Vertical means up or down, right? Vertical translation. Which of those is vertical? The 3 or the 2? The 2. Because the 3 moves right or left, the 2 moves up or down, correct? So this one always gets me my vertical, this one always gets my horizontal. So this is a vertical translation to, which way? Up. If it's a positive k, it moves up. If it's a negative k, it moves down. Then we have a horizontal translation. I should say 2 units. It should say units in here. That's my typo. Horizontal translation. Now it's going to be 3 units right. Because it's an x minus 3, you actually move 3 to the right. Make sure you're copying something down, even if you didn't print notes and then didn't actually ask me to print the notes, so you have no notes in front of you. You should still feverishly be writing at this point, because you didn't ask me for any and you didn't print any. Okay. So do you have them written down? Now, that is the transformed way of telling us what we're doing to this f of x. So we're taking this f of x function, we're moving it vertically 2 up, moving it horizontally 3 right. We agreed the whole graph. Okay? There's something called mapping. Mapping is like, here's a coordinate on the graph. Here it is. It's an x, y. Look at it. Isn't it pretty? X, y, comma, brackets. Here it is. Okay? And I want to do what with this little, I look like a rabbit or something, but I'm not. So, we have a coordinate, and we're doing what with it? 3 to the right and 2 up. We agree? Probably didn't have to go 2 down. 2 up. Okay, so here we are. Boom. Little xy coordinate. Here we are. And we're going to go a 1 and a 2 and a 3 to the right and a 1 and a 2 up. So I'm going to end up here. Do you agree? And I'm going to move every single coordinate on that graph like that. Do you agree? So mapping is just another way of showing how I move a coordinate to my new coordinate. Okay? And sometimes they just ask for mapping. It's shown up here, but we're going to show it over here anyways. So mapping is just another way of representing words. Mapping in words, I'm going to put it in the heart. These are the words. We agree? The words are, I'm vertically translating it 2 units up, I'm horizontally translating it 3 units right. Mapping is the coordinate. So I'm going to start with an xy coordinate. I have to show that because that's my original. So I go xy. If you don't have that, you do not have mapping. So original coordinate xy, here it is. And now I'm going to make it become. So I'm going to use an arrow. And I have to use an arrow. If you use an equal sign, you're wrong. If you don't have the xy to the arrow, you're not doing mapping. So I have my xy, and I want to move it 3 to the right. So what am I going to do to that coordinate to make it go 3 to the right? X plus 3. And then I need to move 2 up. What am I going to do? Y plus 2. So now we're going to say, so if the point 4, 6 was on the graph of y equals f of x, so this is on the original graph. Then the point becomes 7, 8. Then it becomes 7, 8. How can we prove that? What can we use to prove that that actually works, that that actually happened? Because you used mapping. You used your mapping. So let's prove it that way. So how we can prove that works is we write our mapping. X, y becomes x plus 3, y plus 2. So if I ever want to move a coordinate, I use mapping. If I want to move a graph, which is a whole bunch of coordinates, I use mapping. Okay? So the original was 4, 6. So I'm going to put it here. And then I'm going to go arrow 4 plus 3, comma 6 plus 2. And then another little arrow, 7, 8. And I just proved it. Right? And it worked. So what if I have more coordinates on my graph? Just plug it into mapping, get a new coordinate, sketch it. Plug it into mapping, get a new coordinate, sketch it. If I had 10 coordinates, I'd do it to all 10, and then I'd sketch my new graph, and I'd be done. Right? So words are important for the fact that they'll ask you to describe, or they'll ask you to state the transformations of the graph. But mapping is important when you're moving points or you're moving a graph. Okay, then we're going to flip over. So here we're going to describe. We'll do the first 2, and then you're going to do the last 2. So describe. What is it? And we're going to use mapping. We don't have it in here, but describe and map. Doesn't make real words sense, but that's okay. Describe and mapping. Describe means state transformations. Mapping means mapping. It's crazy. So describe how the graph of the following function relates to the graph of y equals f of x. So the original graph y equals f of x is the original, and now it's saying, okay, to f, I want you to do that. Do you see that? To f, I want you to do that. So my s would be blank, my r would be blank, my t would be what? Yeah, so we don't have to state the vertical. You were overachieving there, so that's good. We only have to state the horizontal if there is no vertical. Look at you, mister. I had a 60 and I didn't actually have a 60. Horizontal translation. Three units, what? Yeah. And why is it to the right, Talon? We always do the opposite. With the x, we always do the opposite because it's x minus, and then your h is actually the number beside the minus sign. And so then your h is a positive 3. So that's why we're moving 3 to the right. Now there is no vertical translation, so we're done with describing. But I want to do mapping still. So I have a coordinate. It is an xy. I now want to move it 3 to the right. How do I move xy 3 to the right? X plus 3. Does anything happen to my y? Nope, just stays a y. Boom, done. When I go to B, I don't have any stretches or reflections. Why? Because we haven't got there yet. So that's a giveaway that the S and the R will be blank. The T, is this with my X, this 4? Or is my X sitting alone here? My X is sitting alone. So do I have a horizontal translation at all? No. What do I have? A vertical translation. 4 or units up. How do I move my mapping? How do I move a coordinate if I want to take it and move it 4 up? X and then y plus 4. You're doing C and D, same thing. State transformations and mapping. What about this one? It's only translations. What is it going to be? Vertical translation, yeah. Eight units down. And mapping, x, y becomes x and then y minus 8, because the y is the only one being affected because I'm moving down. D has a vertical translation. 4 units up, and a horizontal translation.
7 units left.
Yeah. Seven units left. And mapping is literally just moving it. So if I have x, y, and I want to move x 7 units left, I'm going to take x and I'm going to minus 7. So moving it 7 to the left. And then my y, I want to move it 4 up. So I'm going to take my y and I'm going to add 4. So your mapping and your words should be the same. If you think you're mapping, I just need to move this point. I need to move it 7 left. Well, I'm going to have to subtract 7 off of it. Right? Okay. We're going to do a little bit of replacement. So here it says, what happens to the graph of y equals f of x if the following changes are made in the equation? So we're going to replace x with x plus 2. So we go to our function, we take this x, we're like, no thank you. We toss it behind our head and we replace it with x plus 2. I got a little aggressive, it kind of covered over that. But we're going to go y equals f, toss the x out, and replace it with x plus 2. When you replace doesn't mean you keep it. Replace means you take the x, toss it away, put in the x plus 2. So what do we have happening here? What kind of translation? Horizontal translation. 2 units left. And you guys, you need to know all of these lessons backwards and forwards and not be mixing them up at all, because tomorrow we're going to add another lesson on, and Monday we're going to add another lesson on. And so if you don't know your lessons as we go along really, really well, once I start adding the third one, you just mix everything up, and then it goes really badly. So if I do this in mapping, I'm going to get x, y becomes, if I want to move to the left, I'm affecting my x, and I want to move 2 to the left, so I'm going to minus 2. And then nothing happened to my y. Now we're replacing our y with y minus 8. So our function is y equals f of x. So I'm not putting a minus 8 at the back, I'm replacing the y. So I'm taking the y out of the function, tossing it behind my head, and I'm replacing it with y minus 8. And then I still have an equal sign f of x. You see how replacement gets replaced in for the y? So I take the y, toss it out, replace it with y minus 8. And then what I tell you to do always before you actually state anything? Get y by itself. So I'm going to add the 8 over. So I get y equals f of x plus 8. Now what transformation is that? Vertical translation. Eight units. What would my mapping do? So your xy becomes, x stays the same and your y adds an 8. Okay, example 3. The point 2, -3 lies on the graph of y equals f of x. So this is on the original graph. That's telling me. They want you to state the coordinates of the image. The image is just the moved coordinate. State the coordinates of the image of this point under the following transformations. Okay, state the image of these under the following transformations. I want to move a coordinate. If I want to move a coordinate, what should I use? Mapping, every single time. I want to move a coordinate, use mapping. I want to move a coordinate, use mapping, every single time. If I want to move a whole graph, which is a whole bunch of coordinates, I use mapping. It should be embedded in your soul by the time we're done this year. Okay? So we're moving a coordinate, we use mapping. What's the first thing I have to do in order to get mapping? Get y by itself. So I'm going to subtract the 8. So I'm going to get y equals f of x minus 8. What is that? Vertical translation, 8 down. So I need mapping, so I don't need to write the words, correct? Because I'm just moving a coordinate. So I have xy becomes, my x is still just an x, so x stays the same. And my y, I need to go down 8. So I'm going to go y minus 8. Once I have mapping, the rest of the question is really easy. I just plug the point in. So I'm going to go 2 and -3 becomes 2, comma, -3 minus 8. So my new point is at 2 and -11. Now people might say, why do I have to use mapping when it's this easy? Because it's not going to always stay this easy. But we can check it. So we were at 2 and -3. I need to move it 8 down. So I'm 2. I'm at -3. I need to move 8 more down. Boom, 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 boom. 2 and -11 makes sense. Right? You guys are going to try B. Once you've tried B, and then try example 4. So this one, our mapping is going to be xy becomes 7 to the right. So I have to go x plus 7. And 5 up. So I'm going to go y plus 5. And I plug in 2 and -3. And it becomes 2 plus 7, -3 plus 5, which is 9 and 2. Then I told you to try example 4. So example 4 is reverse. It gives you the transformations and wants the equation. Now, this is the key thing about 30, which makes it harder than 11 in a lot of ways. So 30, I can give you the equation, ask for the transformations. Give you the equation, ask for mapping. Give you the equation, give you a point, move the point. Give you an equation, give you a graph, move the graph. Then I can give you the words, ask for the equation, ask for the graph, ask for the point. Like I can give you the mapping, ask for the equation, ask for the transformation. So like I can give you any varying level and make you give me the other versions of it. So you need to know your stuff backwards and forwards, okay? So here we want a horizontal translation, 5 units left, from y equals f of x. So we're going to get y equals f, and then what? X plus 5. So we know that words and mapping are the same. But we do know, so those will always be the same. If I add 6, I add 6. If I add 7, I add 7. If I'm minus 2, I'm minus 2, right? But when we go from words or mapping back into the equation, the x's always flip. Or words or equation to words and mapping, the x's always flip. So we have vertical translation 3 up. We can go y equals f of x plus 3. Or they might give you the version where the 3 is with the y. Y minus 3 equals f of x. And if it's with the y, it actually does the opposite. So when it's with the variable, it always does the opposite. And then C says a horizontal translation of m units right and a vertical translation of p units down. So we're going to go y equals f. M units right, so we go x minus m. And p units down, minus p. Or, the p could be with the y and be the opposite sign. I only write the second version because that's how they could have it as multiple choice, but I will always fill it into the y equals. Then we're going to flip over. Like I said, if you're someone who does not have a printer, you should ask me for printing. Okay. So here it says, in each case of graph of y equals f of x is shown, sketch the following transformations for each. So we're moving a graph. A graph contains just a whole bunch of coordinates, right? When you move coordinates, you use what? It needs to be embedded in your soul. It's not there yet. When you move coordinates, you use mapping. Mapping, 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 mapping. So when you move a graph, you're moving more coordinates. You still use mapping. Now people will say, I can just move these easy. Remember, we're practicing for when it's not as easy as it is right now. Okay? We're practicing, practicing, practicing. So this is x minus 2. What does that mean in description-wise? Horizontal translation, 2 to the right. So our mapping is going to be xy becomes x plus 2 comma y. Now, like I said, I know 2 to the right, we could just go boom, boom, and draw it. Correct? And we could get a new graph. I get that. But we are going to practice it as if it's not as easy as that because it's not going to stay that easy. All right? So I'm going to put this coordinate in. It's 1, 2, 3, 4, 5, 6. So it's negative 6, 0. And then I'm going to plug it into mapping. So I'm going to get negative 6 plus 2 comma 0, which becomes negative 4, 0. Then I plot the point. And then I go to the next coordinate that is next to it. I go to the next coordinate that is next to it, find its new point, connect them. Next coordinate next to it, find its new point, connect them, and just keep going. But I connect as I go along, or sometimes you give me like almost looks like a lightning bolt, but it shouldn't. It should be connected differently. So connect as you go along. So we go to the next one. It's at 1, 2, 3, 4, negative 5, and negative 3. And so it's going to be at negative 5 plus 2 and negative 3, which is negative 3, negative 3. So I go to it, I plot it, and I connect. Do you see that? Immediately connect. Then I go to the next point. The next point is this one up here. It's at 1 and 1, 2, 3, 4, 5, 6. 1 and 6. It's now going to be at 1 plus 2 comma 6. So it's going to be at 3, 6. And then I connect those. Then I go to the next point, which is 3, 6. And we get 3 plus 2 comma 6, which is 5, 6. Connect those. And 1, 2, 3, 4, 5, 6, and 0 becomes 6 plus 2 comma 0, which is 8, 0. Now, does it look like I moved the whole graph to the right? Yeah. Could I have just moved it to the right quickly? Yes. If it was short like this, that's what I would expect on a test. But we're going to add a whole bunch more things to it. Okay, I want you guys to try B. Move the 2 over first. Try B. You don't have notes? Sketch it anyways. So our mapping is going to be x, y becomes x minus 3 comma y minus 2. And you should get a graph that's like here, here, Okay, this one here says state the coordinates of the image of the point under the transformations described. So I want you to give me the new point, and I want you to state the transformations. So now I'm giving you mapping, and I want the transformation stated. Okay? So I want you to give me the new point. So for example, this one would be -3 and 5 goes in here, -3 minus 7, comma 5 plus 4. So my new coordinate would be -10 and 9, which is an easy question. If they give you mapping and just ask any point, right? What's harder, though, is if they want the transformations. What does this x minus 7 mean? Horizontal translation, 7 what? Left. Because mapping and words are the same. I have an x, I'm going this way. I'm minusing 7 from it. So which way am I going? To the left. So this is a horizontal translation. Seven units left. And this, I have a y, I'm adding 4. So I'm moving. Vertical translation. Four units up. You try B. So this one, if I plug it into mapping, I'm going to go -3, 5. And I'm going to go -3 minus 6. And then I'm going to go 5 plus 1. So I'm going to be -9 and 6. So even if you don't know what the heck's happening, if you're at -3 and 5, you're here, you're now at now you're at -9 and 6. Somewhere over here. What did you do? You moved up and to the left, correct? At the very least, you could visualize it. So this here is a horizontal translation. Six what? 6 units to the left, yep. And then this is a vertical translation. One unit up. So it's not like in the equation where you do the opposite with your x's, correct? You have to spot between mapping and words, same thing, right? And then equation, it's opposite. Now, these ones aren't f of x equations. Everything we've done so far is here's an f of x equation, here's what we do to f, right? These are, here's a degree 4 equation, here's what I'm doing to it. So the transformations that happen are only the things that have changed. So here we have y equals x to the 4, and it's in brackets. This is still x. Does anything happen to my x at all? No, what did I do though? Vertical translation, 3 up. 3 units up. For B, the 6 is still there, right? The -3 is still there, so I don't state those because those were there, still there, correct? So what's the only thing that's changed? The x has become x minus 1, so that is a what? Yeah, horizontal translation 1 right. One unit. You try C and D. Remember, if it's with the x, it doesn't matter if it's on the bottom. This is still 1 to the left, right? So try out C and D. So these are different than the previous ones because the previous ones were here's f of x, and then I gave you an f and told you. So if I gave you f of x, and then here I gave you an f, it would be like, these are the transformations you're doing to this, correct? The ones I'm giving you now is, this is an absolute value function. How did it change? This is a radical rational function. It's crazy. How did it change? That's it. The ones with x in them, that's just another way of saying the transformation. So move it 3, do this. You do all of that. These you compare, because it's an absolute to an absolute. This one has moved nowhere. This one is a horizontal translation. Uh, 6 units to the... No. It's overthinking. It's just the same rule. If it's minus, it goes to the right. If it's plus, it goes to the... No. No. Doesn't matter if it's an absolute. Didn't matter if there was smiley faces around this baby. Is a good meat source in a sandwich. Okay, then vertical translation. 2 units. Where? Up. This one is a horizontal translation. Here's where the x is. Here's where the x is. What happened to my x? Horizontal translation. 1 unit left. If it's with the x, it's left or right. And then this was a 0. It's now a 3. So vertical translation. 3 units. Yep. It's always the opposite.
Yeah.
This one's right because it's x minus 6. This one's left because it's 6. No. It's not the absolute value. You're not like solving for the variable. So this is an absolute value function to an absolute value function. It's just how they changed. Yeah. Okay. Let's look here. Here it says, write an equation of the image of y equals x squared after horizontal translation 3 units to the right. Horizontal affects the what? The x. And when you go from transformation into equation, what does it do? Opposite. Yeah. So if we're going 3 to the right, and I'm putting it into my equation, I actually have to put in x minus 3. So I'm going to get y equals, in for my x, I'm going to put in x minus 3, and then squared. When you're done the equation, you should know if you're right or not, because you can work your way back. What would I say about this if I looked at this equation? Oh, from here to here, I went horizontal translation 3 to the right. Ah, it matches it. Most people are really good from equation to words. Words to equation, a little dicey. But if you have the equation, you can work your way back and see if you get your words, right? This one is a vertical translation 2 up. Vertical translation, does it go with the x? If it did go with the x, it'd be in this little exponent up here. It would join it. That's where it would be. But it doesn't. It just goes to the back. So we get y equals 10 to the x, and then plus 2. Because vertical is always the same. Whether it's mapping, words, or graph, or equation, always the same. This one, y equals root x after a horizontal translation 4 units to the left. Words into equation, what am I going to do? Yeah, the opposite, so I'm going to add. So I'm going to get y equals square root, because it has to go with the x, and the x is into square root. X plus 4. And vertical translation 3 down. Nice. This one we just have to read a little thoroughly. It says, the function represented by the thick line is a transformation of the function represented by the thin. So the thin's the original. The original is f of x. So what did I do? I went 2 to the right, and I went 4 down. So I'm going to have y equals f. If I want to go 2 to the right, I'm going to actually need what? X minus 2. And I want to go 4 down, so I'm going to minus 4. And then they're the same thing, different pile. I think there's, oh yeah. We have one different kind left. Ah! No, I did. When you're done this, we're going to flip over. Just doing A. I'm going to flip it over. Okay. When we go here, this one only works because we have one transformation. So here it says y equals root x is a radical function, which it is, square root function. What vertical translation would be applied? So we need a vertical translation. Does it say anything about horizontal? If there's no horizontal, what can we say? The x did what? Stayed the same, right? So here it says, what vertical translation would be applied to y equals root x so the translated image passes through 16.7? So they gave us the new coordinate. And then they want what happened, what it was before. Because if I find out what it was originally, then I can figure out how I need to move it to get to 7, right? Because I need a vertical translation. So if there's no horizontal translation, this 16 was what here before? 16. That didn't change, did it? How can I get the original y? Plug 16 in for the x in the equation. Because the original equation is y equals root x. I know that x is 16, so I get y equals root 16. So y equals 4. So what did I vertically do? Vertical translation. Yeah, vertical translation 3 units up. Because I went from 4 to 7. I was 16 and 4, I'm now 16 and 7. I moved 3 up. The next one is the opposite. It says what horizontal translation would be applied. So what's not moving? Y. So 17.8 is my new point. What was it? Well, it's something in 8. We know that much. We know it's something in 8. How do we get that something? Yeah, so you're going to plug it in to the equation y equals root x, but you're plugging it in for the y this time. So you get 8 equals root x. And how do you get root x by itself? Square it. So x actually equals 64. So we're going from 64 to 17. We're going from 64 and 8 to 17 and 8. 64 and 8, 17 and 8. Which way are we moving? 64 and 8, 17 and 8. Left. So horizontal translation. $47 units. I'm going to cut that down a little bit. So you have like 22 minutes. You should work hard because this is part of the homework that's due. So page 12. I'm just going to get rid of this one because 4 is better than 2. Okay, we're